slope of a tangent line, and we found two different formulas for that. We know slope is rate of change, so you have to have two order pairs. So we did one option where we just took 2 points on our curve. So A, f of A, that was the one we were concerned with, if I wanted slope there. And if I wanted to find slope, I had to have some other point on my graph, x, f of x. We know slope between them is y2 minus y1 over x2 minus x1, thank you. But if I want the true slope, just like when we made those tables, those numbers had to get closer together. So we do the limit as x approached A. That was the definition 1. Definition 2 said another way to think about it is if I want the slope of the tangent line at this particular point, A f of A, you could take another where it's just A plus a little bit, and you have to plug that in to get the y. So the slope, y2 minus y1 over x2 minus x1. If you do that, what happens to your a's? They cancel. So it's over h. And if I want this to be the true slope, these need to be getting closer together. So I need to do the limit as h is approaching 0. So those were the two definitions. And Grant, if you need to be working on your study guide, you're welcome to do that. And then, yeah, if you haven't watched the video from that, it probably won't make sense.
Oh.
So.
I hear it like already like.
Yeah. We gotta get those flippers.
The flipper wet jet.
Yeah, it works out well.
Thank you. So it turns out that this slope is just a rate of change. Well, this particular rate of change comes up in a lot of different problems. Like if you're talking about sciences, you know, chemical reaction, engineering, marginal cost, and economics. This calculation is extremely important, and this is why so many non-math majors have to take calculus, because of this right here. So this is a rate of change, and it is called the derivative. Now, we had two definitions. You notice I'm using the second definition because we talked about Friday in terms of simplifying. A lot of times it's easier to cancel just a single term off the denominator rather than multiple terms, less factoring and reducing. So this is the derivative. The notation is an f prime, one tick mark. That will now represent derivative. Thank you very much. Anytime we need it. And like we said, it could be either definition. I just typically use the first one. So let's find the derivative of this function at the number a. So you notice, did I even give you an actual number to plug in?
No.
No, we are keeping in terms of a. So our definition is the limit as h approaches 0, f of a plus h minus f of a all over h. Now those first few homework questions, you were doing slope at a particular point, so you had an a to plug in. I don't here, so I'm just working with this. So limit h approaches 0. This is where I see the most mistakes, right here. F of a plus h. What does that mean?
It's x equals a plus h.
Yes, I am replacing my x with a plus h. Minus, what is f of a?
Just a, x equals
I have a lot enough space.
All over h. I almost didn't. So now we just work this out. So we have limit as h approaches 0. A plus h squared. So if I write that twice in FOIL, we get a squared plus 2ah plus h squared. Distribute my negative 8, so negative 8a minus 8h plus 9. How do I subtract that off?
Plus minus.
Okay. Then a squared and negative a squared cancel. Negative 8a and positive 8a cancel. Positive 9 and negative 9 cancel. So I am left with 2ah plus h squared minus 8h divided by h. What do we do? So then if we plug in a 0 for our h, we get 2a minus 8. So now I have the derivative. So if I asked you for the derivative at 4, what would you do?
Plug in a 4 would be 0.
We could plug in a 4 for the a and we get 0. If I said I want the derivative at negative 3, plug in negative 3 and we get negative 14. So we found a formula for finding our derivatives here. Yep. Yep. It'll work as well.
Why did you get rid of that h then?
Oh, h was approaching 0. So it turns out that what we just did is the same as we were doing last week when we were finding the slopes of tangent lines, right? So the slope of the tangent line is the derivative. So if I asked you to find the equation of the tangent line to this function at the point 3, negative 6. We know if we want the equation of a line, we need a point and a slope, right? We found from example 4, our derivative, which I just told you is the same as the slope, was 2a minus 8. What's my a equal to?
Negative, or positive 3.
So my slope is negative 2. So then we can do y equals mx plus b. So y-intercept is 0. My equation is just y equals negative 2x.
I don't know you had to be. Does that first equation not matter anymore?
Right.
Okay. He's not here, you won't see that.
Oh yeah, that's true.
Oh, so I was gonna tell us everything.
Okay.
Thank you.
Yep.
So I just want to confirm, x and a are the same. Okay.
Alright. So what we've learned so far, derivative is the same thing as slope of a tangent line. Right? We also know that the slope of a tangent line we talked about is an instantaneous rate of change. So a derivative is an instantaneous rate of change. It's how things are changing at a particular point in time. So let's look at this example. A manufacturer produces bolts of a fabric with a fixed width. The cost of producing X yards of this fabric is C equals F of X dollars. What is the meaning of the derivative F prime of X? What are its units? Okay. That's the same thing for derivative. That's the notation I told you a few slides ago. When you see that prime, that just means derivative. So what is a derivative? Well, we said it's an instantaneous rate of change. So if I'm talking about my cost function, it's how the cost is changing at a particular point in time. Okay, so it's how the cost is changing at a given point. So derivative is a rate of change, how it's changing. If I want our units, think about when we find this. Okay, we said the derivative is this f of a plus h minus f of a over h, right? That's just a slope, y over x, change in y over change in x. So if we think about it in terms of our problem, if I did change in y over change in x, what's y measured in?
Dollars.
Mm-hmm. Per, what's x measured in?
Euros.
So my units would be dollars per yard. In practical terms, what does it mean to say that f prime of 1,000 equals 9? 1,000 is the x. What does x represent?
Yards.
$1,000 per yard. No,
1,000
yards per $9.
Okay.
Sorry.
But it's not telling us the cost. It's telling us how the cost is changing.
Oh.
So it's saying when 1,000 yards are produced, are the costs going up or down?
Up.
And how do we know that?
Positive.
So the costs are rising. 9, and we already said our units would be dollars per yard. So what that means is if I make 1,000 yards of fabric, I would expect if I want to make another yard, it would cost me an additional $9. Okay, it doesn't tell me what it's actually costing, just how that cost is changing. All right, part C. Which do you think is greater? F prime of 50 or F prime of 500? So keep in mind, prime is how the cost is changing. Okay, so think about in general. If you are ordering t-shirts, okay, what happens if you have 15 t-shirts to design? Is your cost high or low per shirt? It's usually higher per shirt because they charge you the design fee, and you have to get them printed. But what happens if I say, okay, I don't need 15 shirts, I need 50? What will happen to my cost per shirt?
Goes down to the bulk.
It goes down a little bit, right? When you order in bulk, they're usually slightly cheaper. So, as my number of x's is going up, what should be happening to how the cost is changing, the derivative? It's going down. Your eye okay? So I would expect that the rate of change at 50 would be greater than 500. If I'm only ordering 50 to order one additional shirt, will probably cost more than if I'm making 500 and order one additional shirt. Do you guys agree with that? Mm-hmm. Okay. Now here's the next question. Does that work forever, or is there a stopping point? There's a stopping point. If I go to CW's and say I need 5,000 shirts, do they have the capability in there to make me 5,000 shirts? No. Okay, if I'm talking about a bakery, if I'm producing 500 cupcakes, fine. But do you think I can make 5,000 cupcakes?
No.
No. If I need that kind of quantity, what am I going to have to do? Okay, we're going to have to get bigger equipment, hire help to come in, right? At some point, the scales tip, and we no longer have the ability to produce that large of a quantity. So at some point, adding one more is actually going to cost me additional money. Does that make sense? because you can't just add more forever. At some point, we have to bring on additional staff or update our equipment or something like that. Now, do I know for sure what that is? No, not in this case. Till we find it. So I'm just going to say f prime of 5,000 may be more costly if production becomes inefficient. If I don't have enough workers or enough machinery to produce 5,000 bolts of fabric or 5,000 yards of fabric, then I have to upgrade everything. And now that's going to cost me a significant chunk of money. All right. Questions there? So I have really taught all the content. Now we just are going to practice for a while. So I might save some of these for tomorrow. We'll kind of see. I'll do some today and some tomorrow. If this is my graph of g of x, I want to arrange the following in increasing order and explain our reasoning. Okay. 0 is pretty obvious. That's 0, right? When I say g prime of -2, what does g prime mean? The derivative. Okay, in terms of a graph, we know now that a derivative is the same thing as the slope of the tangent line. So if I were trying to estimate the tangent line right here, remember that's the line that touches it, just at that point that it's not a great point. Okay, so it looks something like that. So it's a positive, would you agree? The graph's increasing, my tangent line's increasing there. Okay, g prime of 0. So that's the derivative at 0. What kind of line is that going to be?
Linear.
Most lines are. But it's decreasing, so it is negative. All right, so if I'm putting these things in order, so far, g prime of 0 is my smallest. 0 is in the middle. We said g prime of -2 is positive, so it's going to go like this so far. G prime of 2. So if I estimated my slope at positive 2, is it going to be positive or negative?
Negative.
At 2,
I don't know how to read what they're doing.
is the line increasing or decreasing? So it's kind of telling if the graph is rising.
Are we talking about y?
Hmm?
Are we talking about y?
Well, I was just talking about, why this line is why this derivative would be positive, because the slope of that line is positive.
It goes up.
I'm not picking up what you're putting down.
Okay. Do you get why I drew that line?
Yeah, because that's the point. That
Mhm.
tangent line does
So
that.
a g prime is just the slope of that line. This line is increasing, so its slope is positive.
Why is this one positive?
It is.
No, why?
As you go from left to right, the line is rising. That one's negative because it was falling. And that one's positive. Okay. So, kind of hard to tell there. Both my purple and my blue one are positive numbers, right? Which one is steeper, do you think? 2. So that one would be bigger. Okay. The other one, we have g prime of 4. So at 4, if I do my tangent line, is it a positive or negative slope?
Positive.
Slightly positive. It's positive, but it's pretty close to 0, right?
Yeah.
So if I'm putting these things in order, it will go between 0 and that. So, my smallest is g prime of 0. Then we have 0, g prime of 4, g prime -2, and g prime positive 2. Was it on the ACT?
I don't remember. I was just saying imagine.
It could be.
I like had the violent realization Saturday that the ACT is this Saturday, and I'm not prepared.
Oh.
4-day weekend.
Oh, yeah. See, you got plenty of time to prepare over the
I
weekend.
have plenty of time to sleep.
I'm so
We're
glad
gonna
I
catch up on
changed the
sleep.
dates.
Alright, I think I'm going to do this one tomorrow. I want to do this one today. So we're kind of skipping around a little bit. I've covered all the new stuff. We'll go back and hit the ones I skipped tomorrow.
Let's take another tea.
Alright, so if I ask you to find f prime of a, so I'm not giving you an actual number to plug in. We are doing our definition. So that is the limit as h approaches 0, f of a plus h minus f of a all over h. So limit as h approaches 0. F of a plus h, so I'm replacing my t's with an a plus h. Minus f of a, replace your t's with an a. Alright, are you guys with me?
Why don't this stuff?
Alright, I need to do a plus h cubed, don't I? It means you have 3 of them. So if you multiply 2 at a time, so then a times a will be a cubed plus a squared h plus 2a squared h would be 3 a squared h plus 2ah squared plus 1ah squared would be 3ah squared. H squared times h squared is h cubed. Could also use that pyramid trick that I showed you at the beginning of the year for that. Still have, let's see. So I distribute my 2. Is everyone with me so far? Okay. Then if we combine my terms, 2a cubed and negative 2a cubed cancel. Positive a and negative a cancel. So I have 6a squared h plus 6ah squared plus 2h cubed plus h over h. Now we can finally take an h out of everything. And now if h goes to 0, what do we get out?
6a squared plus 6a.
6a squared, no, the 6a would go away because h is going to 0.
No, you still have. Oh, they multiply. You are correct.
So it'd be 6a squared plus 1. Alright. I'm going to do one more today and then tomorrow we'll finish the others. Let's go ahead and do b here.
I was looking at C and I was a little afraid. I don't have the capacity for C right now.
And the limit as h approaches 0. F of a plus h. Can I go ahead and say x to the negative 2 is 1 over x squared? So f of a plus h would be 1 over a plus h squared.
Oh, because you flipped it because it's negative. Got it.
The negative exponent, we just put it on the bottom. Minus f of a, so 1 over a squared. All over h. Okay, if I'm just looking at this top, what do we have to have in order to put these together? So I'm gonna take this one times a squared on top and bottom. Mm-hmm.
This hurts.
A squared plus h squared. Now what? Combine. My denominator is a squared plus h squared. Can I multiply out the top? Be a squared minus, if I FOIL over here, a squared plus 2a plus h squared. This whole thing was divided by h, so I'm going to write times 1 over h. But we will multiply. Distribute our negative. A squared and negative a squared cancel. Now what?
Plug in 0.
Not yet. So gives me 0 on the bottom. Since I can't put in a 0 here.
Oh, just
So
like
the
take
H
out
on
the
the
H's.
top.
Mm-hmm.
My bad.
Take out 1 h from everything, then that's gone. So then we can plug in 0 for our remaining h's. So we get negative 2a over a squared times a squared. Negative 2a over a to the 4th, or negative 2 over a cubed. So you know everything to do all the homework. We have more examples we are going to do tomorrow, but I want to give you guys some time to work homework now. So I think I told you Friday you could even go up to through 13. You could technically finish it all. This will be due Wednesday, so tomorrow we will do the last 2 examples. You'll have some work time in class again.